Welcome to the Building Web3 Podcast. I have my good friend Kendall at Proximity Labs. Quick disclaimer, we app only for informational purposes, and any views expressed by anyone on the show are solely our opinions and not financial advice. Jax and our guests may hold positions in the companies, funds, or projects discussed. Please do your own research. Real quick, can you tell us what your role is? And we'd love for you to explain what NEAR is to the audience. Maybe they've been living under a rack or something of that nature.
Yeah, absolutely. Hey, everyone. My name is Kendall. I'm the co-founder of Proximity. So Proximity is a research and development firm for the NEAR ecosystem. Primarily, we focus on a product called chain signatures that basically enables smart contracts on NEAR to sign transactions for any chain. And very excited to announce, actually, we're launching a product called Based Agents that's going to be end-to-end verified agents. So TLDR, fully trustless agents for the first time ever. So NEAR itself is actually a public proof-of-stake blockchain. For a long time, kind of one of our core differentiators is that we scale horizontally, and thus we believe as close to infinitely as you practically need through a technique called sharding. Over the last few years, we've really been focused on a couple of specific areas. So one is basically any chain interactions, basically empowering NEAR builders to actually build applications that use any crypto asset. So we have a lot of teams building on Bitcoin, for instance, right now, since it's one of the few ways you can actually utilize smart contract functionality while still custodying Bitcoin in a trust minimized way. And then over the last year or so, we've really been focused on ways that builders who are interested in exploring new projects that are empowered by artificial intelligence can actually do this in a way that's true to crypto's values, which primarily is verification and trust minimization, and more recently, privacy.
All right, we have a very technical audience, but in case somebody isn't as technical, let's start at the very beginning. What's the difference between vertical and horizontal scaling? Because they're doing horizontal scaling with sharding.
Yeah. So vertical actually is pretty easy. Think of like Solana. Solana just basically adds beefier and beefier machines and different techniques in order to get more throughput. Horizontal is what we do is we actually basically create a bunch of mini chains. So basically, instead of having a single validator set that verifies every single transaction that comes through the network, we actually split into these subcommittees where each committee only verifies like 1/10, 1/100th of the transactions, but then they combine that work into a single canonical blockchain. So for users and developers, it feels exactly the same as using any other blockchain, but what's actually happening and how it's sort of scaling is a bit different.
And then I want to talk a little bit about chain signatures, because we've had a lot of people on here like Particle, Omni talk about like chain abstraction, and even account abstraction has been talked about a lot. But what is a chain signature?
Yeah, great question. It's definitely something that we've kind of introduced to the industry. So the concept is based on a technology called multi-party computation, which basically is a way to do private key management. So imagine that instead of just single user custodying a single private key, you basically organize a group of kind of well-known, trusted parties, or even totally open, anyone can participate parties, and you have each of them work together to basically create a private key that together they can sign for if, say, a certain threshold of them agrees to sign something, but individually they do not know. So what we do is we got together a subset of the NEAR validator set that basically works together to sign using this kind of totally hidden private key. And what they do is they listen to requests, basically transaction requests from NEAR smart contracts, and then they sign those transaction requests, but they'll only sign it from a single given NEAR smart contract. So if you deploy a smart contract and I deploy a smart contract, only I can ask this validator set to sign for the key that's sort of unique to my smart contract, and only you can ask for them to sign for the key unique to your smart contract. So like why that's interesting is basically that it enables smart contracts to sign transactions. And that as a primitive is powerful because it now means that smart contracts on NEAR can sign transactions for any blockchain. Which basically enables a lot of really, really seamless and more efficient cross-chain interactions, or even things like bringing smart contracts to a platform like Bitcoin that doesn't have them.
Yeah, let's use the Bitcoin example, because I think this will be maybe the most eye-opening, because there's some kind of programming language on Bitcoin. It's quite nascent. Like there's DLCs, there's all kinds of interesting things going on there. But everyone we've interviewed, from Robin at Liquidium to pretty much every builder, they're split out and doing L2, or they're just like, building on Bitcoin is like 10 times harder. So talk to us a little bit about how you guys like enable more easy development on something like Bitcoin.
Yeah, great question. So Bitcoin's been a big focus for us because we see that obviously as a huge opportunity for builders and users in the space. It's like very much, it's by far the most important crypto asset and also probably the most underutilized, which is crazy. So yeah, there's two technologies we've introduced. So chain signatures itself is basically smart contracts can now custody Bitcoin. So anything you've been doing with smart contracts in any way, letting users trade assets, like facilitating those transactions as a decentralized exchange, or letting users basically post Bitcoin as collateral and then borrow stablecoins against it, or even potentially using it Bitcoin as collateral for derivatives and perpetual swaps and these type of products. All of that is now very, very possible. And from a developer perspective, it's really simple. It's basically, okay, your smart contract is going to have these basically deposit addresses. These addresses it can request signatures from this chain signatures network for, and then thus move this Bitcoin. So what they can do is they can tell users, hey, deposit to this address. Make sure that they basically can register that deposit happened, and we do that through basically an on-chain Bitcoin light client, meaning that we're actually verifying all of the Bitcoin blocks on Near, and that's a very, very trust minimized process. So basically, as a user, you can send funds to this smart contract. That smart contract can see that your address sent funds to that Bitcoin address. This part now happening on Near, and can credit you that balance, and then it can basically let you say use that Bitcoin as collateral to borrow USDC, which will then be given to basically also your Bitcoin account, even though it'll live on Near. At which point you can deposit it to Binance, you can swap it for more Bitcoin, you can kind of do anything. And then when you want to say maybe repay your loan and then come back and get that Bitcoin back, you pay back that stablecoin loan to this smart contract. Again, kind of you can even really use your Bitcoin wallet to do this. And then you can tell the smart contract, hey, I want my Bitcoin back. I returned the loan. I want to get my collateral. And then the smart contract will actually request to basically send that transaction on Bitcoin. It'll be signed by the MPC network. And then that'll be relayed to the Bitcoin network at which time the user gets their Bitcoin back. So that's basically the sort of back end machinations that need to happen in order to enable this. And then the only other piece of puzzle that we really needed is basically some wallet abstraction, which that sounds fancy, but all it is letting users use their Bitcoin wallet to interact with these applications. So I think there's been a lot of Bitcoin L2s that have popped up. Most of them still use the EVM and thus require users to use something like MetaMask. While most like true Bitcoin users are using other types of wallets. Maybe if they're a little more bleeding edge, they're using like a Unisat or an Xverse to interact with ordinals or runes or something like that. Or they might be more old school and using like an Electrum, or they're an institution and they're using some kind of custodian like a Fireblocks. So our goal was to make it so they can use that exact same wallet with these applications, and they don't have to take any additional steps. And so that's what we've kind of delivered, is the ability to bring any Bitcoin wallet and use these applications, even though technically the smart contracts are on Near and some of the interactions are on Near, but it still just feels like Bitcoin end to end, but faster, right, and you can do more.
Let's imagine I'm an institution. I'm going to be calling myself Jax Rocks, and I've now got some Bitcoin stored up in Fireblocks. How would I essentially use it? It's like, you know what? Maybe I want to get some kind of DeFi yield. Talk us through the end to end, because you talked about how it works on the back end, but for a front end user, how would that necessarily manifest?
Yeah, so two things you have to do. The first is the deposit step. So you will have to deposit to a Bitcoin address or a series of Bitcoin addresses that are controlled by this Near smart contract. And then after that, all you have to do is sign messages using your Bitcoin wallet. So any wallet that supports the kind of Bitcoin message signing standard, which at this point is every single one that I've ever seen, because this is a pretty common pattern for a lot of kind of Bitcoin traditional use cases. And so basically it's like you interact directly with the Bitcoin network in the way that you always have. And then when your assets are now kind of being used in this sort of Near smart contract realm, then you just have to sign messages with your Bitcoin wallet. And then eventually that final message you'll be signing is, hey, I want my Bitcoin back to like my Bitcoin address, and I want to go back to my cold storage. And that'll happen on the Bitcoin network. So it's basically deposit step on Bitcoin, a bunch of signed messages from your Bitcoin wallet on Near, and then basically redeposit withdrawal step back on Bitcoin for any pattern.
Very excited. Now, one thing Near is quite well known for, of course, you guys got now the chain signatures, chain abstraction, the horizontal scaling with sharding. Talk to us a little bit about AI, because like when I think of Near, that's actually what I think of primarily. So talk to us a little bit about like how you guys kind of made yourself the AI chain and how you guys are kind of furthering that mission.
Yeah, absolutely. It helps to tell a little bit of history of Near, because I think it kind of sets the scene for like why we've made such a big push recently. So Near actually, when it was started, it was founded by Ilya and Alex. Ilya was actually coming from Google, and now everyone's heard about this paper that was one of the last things he did at Google, which is the paper that was kind of the basis of the transformer model that's powering all these LLMs that people are excited about. But at the time, him and Alex had come up with this concept of, hey, we think that now is the time that we can use these models to basically replace a lot of coding. Like a lot of programming could just be generated from these models, and devs can be more just kind of like babysitting these kind of generative models and not actually having to do a lot of the programming themselves. And that's actually how they started. And one of the biggest problems that they had was that they needed a lot of training data. This is like before OpenAI had really kind of scraped the entire web and like thrown it all in with a ton of compute into training these models. Eventually ended up working super well. At the time, it was like people were running very, very small models, and so they needed really, really specific high quality data in order to get anything even somewhat usable. And so they were like hiring all these people kind of globally, and both of them are from Eastern Europe, and so they had a lot of really technical people there that they could get to help train these models, but they needed to pay them, and they were running into all these issues with with kind of just like international remittance. And so they started actually using crypto quite a bit, but they were like, oh, this sucks. Like we want to pay this guy $10, 10 USDC, but gas fees on Ethereum are like $7. This isn't actually working out that well. And so then they started thinking about like, well, actually, how can we scale a blockchain? We have some experience in this type of domains. Like Alex said, had built the first sharded database that was ever used in production. So he's like, I think I know how to do this. And look at Ethereum roadmap, blah, blah. Anyway, they pivoted to Near the blockchain. We ended up shipping that. Went through a bunch of different things. And then, fast forward to basically, I guess, 2022, 2023, when all of a sudden these models that they had originally started working with were actually working for real and starting to, it started to become clear, actually, no, now is the time that we're going to be able to really expand just the way that we interact with computers in a crazy way using these models. Like they're finally ready for prime time. They're finally ready for production. And importantly, we also now have scalable blockchains so that we can actually make it really easy for these agents and these models to kind of interact with each other and pay each other. And then getting to what we're kind of doing now with Near, most importantly, we can actually verify these models using a lot of different techniques and make sure that we can actually remove a lot of the downsides of these models, which are whether it's hallucinations, whether it's just like kind of lack of trust, whether it's like user privacy and user data issues, or whether it's like how these models discover each other and then pay each other. So that's kind of like the setting the scene. Now, to make it very clear, like what exactly is Near doing with AI? Well, so first of all, we recognize that like actually most interactions on computer networks anywhere are going to be agent driven, even if they're human originated. It's going to be like humans come up with some intention. Hey, I want, to order a sandwich from, the best sandwich shop, and I want it to get it as fast as it can. And then there's going to be a bunch of agents in the background that are going to work together ultimately to kind of complete that task. They could be involved in every single step of that kind of like flow that right now would just be handled by like a DoorDash or something like that. So most interactions are going to come from these agents. And so we do need really scalable blockchains in order to do that. We also need really, really well-defined payment networks that are kind of agent native. And, fortunately, one of the assumptions everyone's made in crypto is that it doesn't actually matter who's the originator of a request. All that matters is that the request is fulfilled according to the correct rules. Like it could be an agent, it could be human. Blockchains are inherently agnostic to who's actually using them, which is actually really important primitive for these agent-to-agent payments. So the final piece of the puzzle that we see, though, is that these agents do actually need to be run in a verified manner. We need to know which models are being used. We need to have some kind of like checks and balances on when they decide to make a decision like, hey, we should do this. We should send all your money to this account because, this is ultimately according to your goals. Well, there should be some checks and balances on that to make sure they're not going rogue. And then they should also be able to keep your data and your information private. So to make it very simple of what we've actually shipped, it's called the Agent Cloud. So what the Agent Cloud is going to be is basically a verified hosting system for these agents that where the verification happens at the hardware level using a technology called a trusted execution environment, which is now actually shipped by default on like most Intel CPUs and also NVIDIA's latest GPUs. And then it also basically takes a lot of that verification sort of artifacts, which are kind of part of how these hardware manufacturers are proving that the code running in these sort of trusted environments is, what the developer claims that it is. We take those artifacts and then we actually verify them on chain. So that basically gives, and in addition to this verification, we can also have some rules that are kind of set out that can check, like, is the agent trying to withdraw too much from your account? Like, is this larger than the size that you're comfortable with for any individual transaction? Is it interacting with, say, a pre-approved set of maybe it's DeFi protocols that you're comfortable interacting with, or addresses you're interacting with? And then is it running the source code that the developer claims it's running? So thinking of it like we have smart contracts, which, at least with the best practice, those are the developers make their source code public and transparent. They pay for auditors that come in and kind of third party verify that what the developers claim is happening is actually happening. And then they even have like a way for anybody to go view that source code on a platform like Etherscan. So the idea is we want to take that same set of principles and expand it to any type of agent use case or workload, where it's not just the smart contract that you're seeing and very open in how it's running, but actually all of the agent source code, and even extending it to the model itself, which today that's just hard to do because like the verifying these models are enormous, and so verifying them is quite complicated. But fortunately, thanks to hardware level verification, like these trusted execution environments, we are able to have at least some guarantees, some pretty strong guarantees over the sort of sanctity of those models. So the idea is basically expanding the great things we've done in crypto in enabling this verification and this, and in some cases even privacy, and expanding it to any type of software that people are trying to build, particularly this AI agent software, since that's kind of clearly going to be the replacement for most like SaaS and a lot of the software products that people use today.
Yeah, I definitely believe in the agentic future. Actually, my startup, soon to be announced, is all about agents and marketing to agents. So talk to us a little bit about, let's say we have the Jax AI or DeFi optimization agent, and talk to us a little bit about how it works. Like, hey, all of the models are being run in the trusted execution environment. So like, if Jax's agent is doing some nefarious things, we would be able to kind of walk through the logic or what kind of input it was getting in order to like make those particular decisions. Like, talk to us a little bit about like the workflow of like how an agent makes that decision, and then like how we have that like verifiable trail like you guys are mentioning.
Yeah, absolutely. So, well, the first step actually is requiring developers to come up with kind of a reproducible step to build and deploy the agent that they're ultimately going to be running. So that's step one, and this is ultimately on the developer to do this. So if they come up with this reproducible build step, what we have is we have this kind of hardware verified cloud that the developer can then deploy to. And so what that means is that if you deploy this agent to this cloud and you have kind of the clear steps of how to do that in a reproducible way, then I could also come along and deploy your sort of agent code in the same cloud, and then basically compare the two and see, oh, do these match or do these not? So you can basically spin up this instance, tell users, hey, this thing is safe, it's trustworthy, you can use it. And I can come and I can basically check your work and prove like, actually, no, clearly he's running some different code than he's saying he's running. And maybe that's just because they pushed a new version and didn't get around to updating it, or maybe it's because they're doing something nefarious. And so it basically brings that kind of verification and auditability that we basically expect from smart contracts to your kind of agent workflow. So that's like one core building block.
We have the reproducible ability. So it's like, hey, these are the steps in order to deploy your agent. This is kind of how it makes decisions. Now, a lot of like, LLM inference and kind of like decision making comes not only just from like the core model itself, but is also like injected via RAGs. Does that introduce any kind of complexity in terms of being like, okay, now we have this like new additional fresh context window that's being put in there?
Yeah, that's a great question. The answer is that it definitely could. It sort of depends. So what we'll know for sure is what your agent code itself is doing. So we'll know which models you're calling. We'll know which steps you're taking after calling the models. And then we'll also know at least which data sources you're including when you're calling the model. Now, so knowing what those data sources are, how they're kind of populated, all of that definitely could impact the way this is used. Like if that part of the stack, say like some RAG database you're using, is outside of this kind of trust window, then yeah, that could potentially be a vector where you could be like, oh yeah, my code, it's all verified. But actually you can have a place where you can sort of inject in, and we know how easy it is to kind of manipulate sort of AI model responses, especially LLM responses, if you manipulate the data. So yes, I mean, I think again, this is where use case really is really important. If it's, for instance, like a DeFi product where verification end to end is pretty much paramount because it'll be custodying funds, then we actually we have solutions to bring that sort of RAG inside of this trust window as well. If it's like something that's like a game or kind of like less basically there's less incentive to manipulate, then having like an off-chain RAG or kind of outside the trust window RAG might be okay.
Yeah, I forget what guest I had on here, but he was talking about, he's like, we always talk about, SQL objection or SQL injection for, classic, programming on the internet. He's like, people are going to have to think about prompt injection and like whether people would be injecting prompts into like LLM trading sets to produce some kind of nefarious outcome would be quite interesting if someone builds like a prompt sanitization startup there. Maybe it's too low TAM.
It's also really hard. I mean, I think there's been some really crazy attacks on, or like academic papers where you can inject like one very, very specific set of data. Like it'll only, it basically is waiting for like a trigger word. And so like everything will look normal when you're using the model until that trigger word is hit. And then all of a sudden it'll be the injection. So like using models like DeepSeek, for instance, as amazing as it is, yeah, I mean, we could see some like, state level prompt injection attacks like at the model level. Yeah, that's a tricky part of it.
And yeah, you definitely expect this. Now, one question, you guys named it based agent. So when I think of base, I think of, base the chain. Why call it based agent? And like, what's the general like marketing behind this? It seems like it's a new product that you guys are getting ready to announce.
Yeah, that's a great question. So based agent comes after, it was very much inspired by the concept of a based rollup. So like a based rollup is kind of like an L1 native rollup, where in this case, even the sequencer, which tends to be like the most non-L1 native part, is brought into the full, like you're actually using the L1 for that. So what we wanted to communicate to builders and ultimately users is that we actually believe you can create this kind of L1 verified, basically this like trust environment that's as close to the L1 as possible. I mean, in this case, it's not fully the L1. You are using these hardware assumptions, but because you're combining it with smart contracts, you can basically mitigate most of the kind of downsides of the hardware assumptions from the L1. So basically, that's where it comes from. Based agent equals based rollup, but for AI agents, it's like a fully L1 encumbered AI agent.
Yeah, now I'd love to hear a little bit more about the Near ecosystem. Obviously, you guys have had a huge focus on AI. There's been now chain signatures, so there seems to be a focus on really chain abstracted, like chain, who cares? Tell us a little bit about like the Near ecosystem if people haven't really dove into it. I feel like most of our episodes have probably been on Ethereum, Solana.
Yeah, absolutely. Yeah, so Near actually, I think it's funny when people start diving into blockchain data. They're like, oh, Solana, tons of transactions, tons of users, and they're like, oh, Near is actually number 2 for a lot of these metrics. That's surprising. And yeah, part of it's because we've actually been big believers in. I mean, now it's become very popular to say chain abstraction, and people mean a few different things when they say that. A lot of times, probably most popularly, people mean you want to know which chain you're on. But an even more sort of maximalist version of this is that you want to know you're using a blockchain at all. So we actually have quite a few applications where users don't necessarily know they're using a blockchain at all. And so some of the biggest ones that are drivers of that. So Sweatcoin has been, around for a while. It actually started as like basically kind of like an exercise incentive app and still is. And they have hundreds of millions of users. And they actually have been built on Near for several years now, where users can get rewarded in these tokens, whether they know they're crypto tokens or not, for basically completing certain exercise challenges or goals. And they can then use those tokens to basically like get deals at popular retailers and do these different things. And so like they're an enormously popular app and like definitely a big contributor to a lot of the transactions on Near. And the reason that, Sweatcoin built on us is just that it was at the time was like one of the few ways that they could actually manage the costs with having this much throughput and this much users. So that's like, we have a couple different applications like that. There's like some popular kind of like shopping apps particularly in Singapore and Southeast Asia that have been using Near in the background, kind of similar things. They basically give users like loyalty points for basically interacting with these different advertisements. And then users can use those loyalty points for kind of discounts at retailers. And for them, it's just loyalty points. It's not the blockchain, but in reality, actually all of that is on chain. And so there can be an entirely separate kind of composable ecosystem built around that. So that's like a huge set of applications that are driving a lot of transactions. But then we also have kind of more the traditional chain abstraction applications, and the most popular out there is one called Hot Wallet, um, which is actually one of the more popular wallets on Telegram and Ton, despite the fact that almost every single transaction originates as a near transaction, because they're using the chain signatures technology to basically make it very easy for their users to engage with all these Ton applications, but then bridge over assets from Solana, from Near, from Ethereum, etc. And now they're expanding into letting users interact with like BNB Chain, Solana, Sui, all these different networks.
Yeah. So for some inside baseball for people, Ton has this programming language called Funk, which is apparently very difficult, and that people have ended up building abstraction languages on top of it. So yeah, it makes complete sense if you're like, oh, the developer experience is really good on Near, I'll just build on Near. I know it can be chain abstracted irrespective. I remember talking with, this episode, people will have to go back in the archives, but they can go back to when I interviewed Claudio from Metapool, and he talked about like early days when he was, trying to build on Solana, trying to build on like different kind of platforms. He was just like, Near was the easiest, and we just built there, and we like it. So developers, it is a good place to build. So yeah, they actually make that kind of pitch. Like, developers, we just had Mert on here that's like, hey, Solana is the only place to build in 2025. Like, we've got other people that are more like Ethereum maxis. Like, what's kind of your general pitch to a developer that's like, I've got a new project, maybe it's AI related, maybe it's not, and they're like, where the heck do I build this thing?
Yeah, our pitch now actually has gotten a lot simpler. It's like, well, you're going to get pitched by a million different chains. Rather than just kind of hitch your wagon to a single chain and you basically live or die by like whatever the flavor of the week is there. If you build on top of Near, you can actually access every single chain forever. Like even the chains that don't exist yet, the second that they're live, you can interact with them. So like Barrachain launched last week, and this platform built on top of it is called Near Intense. Was the first, they were the first swap platform to support Barra. Like you could a bunch launched after that, but because of our tech stack and how easy it is to launch on new chains, because like we're just supporting signatures. So if a new chain launches that uses one of the basically two signature schemes everybody uses, then we support them. And so you don't actually have to really like make. I mean, like there are benefits to really focusing on a given ecosystem. There's no question about that. But those benefits do ebb and flow over time. And you ultimately, your user, like you want to serve your users wherever they are, wherever they have their assets, and rather than having to like think about bridging and all these different aspects, if you build your product on Near, you can just serve everyone everywhere. Every time a new chain launches, you could go really big on the Solana ecosystem. We have a lot of AI builders. They're like, Solana's the place to be for AI. Great. Build using our tech stack. We're the only ones who can verify your model end to end anyway. You could just solely focus on Solana. But then if you're like, oh, actually, Base is doing some really good stuff. They have some really good user on ramps. Great. Your product already supports that new chain. I mean, it's like some very, very simple work you have to do in order to just like all of a sudden Base users can use it. So that's kind of how we pitch it, is we're like, stop playing the game of having to make such a consequential decision of where you build your product. And I mean, I think the challenge is like particularly Solana and Base, right? Those are two incompatible tech stacks. They're very different. The programming model is very different between the two of them. And so there is actually a lot of tech debt if you like have to move from one to the other. And we've kind of seen that happen a few times. You don't actually have to do that if you build using Near. You can be like, we're all in on Solana, but then Base is great. Easy. None of your core logic has to change. You're just going to be sending transactions to Base now. Simple. Or vice versa. Or some, monad launches or, some new stuff that we're not expecting. Great. Doesn't have to change.
Absolutely. I think that was a great pitch. And then finally, we always ask all the guests, what is an area of the blockchain ecosystem that you feel is underdeveloped? We always are looking, we've got a lot of builders that listen to the podcast. We're always looking for startup ideas. So what's something you feel like people should hop on or might be big in 2 years?
Yeah. Well, a couple that come to mind, but I think that given the time of this one, when there's a lot of kind of, I think, people are concerned about meme coins. Let's put it that way. So I think that, I mean, ultimately, as great as meme coins are, we need quality assets in crypto. We've actually, most of what we've built as an ecosystem has been infrastructure. Like DeFi is just infrastructure. It's really, really interesting infrastructure. It has a lot of properties. Like it's way more permissionless. People can just launch assets there, and they get all these things that would take mountains of lawyers and like decades to get anywhere else. But the quality of the assets still matters. So like I want to see more people, I think, thinking about what kind of internet native but actually still high quality assets can we generate or create, or even just like bring into the fold a bit better than we have before. And I think we're starting to see people see. I mean, there's this team building kind of like uranium markets on chain that I was just hearing about, and they're like, well, the uranium spot market doesn't really exist. And we're like, so we want that to exist, and the easiest way to do it is actually just to take advantage of crypto rails, because like we can do the legal work to get the spot product like trading, but then all the trading infrastructure already exists, and then it can immediately be borrowed against, and like all that stuff just happens once it's launched. And so I think there's an insane opportunity now, especially with the US kind of waking up from a regulatory perspective, where people are just going to be able to bring like net new assets. They wouldn't even have to be crypto assets; they'll just be assets, but they can take advantage of all this infrastructure we've literally spent a decade plus building.
Absolutely, absolutely. And tell us a little bit about the upcoming milestones and developments people can look forward to. I know you guys have some programs coming up. Talk to us a little bit about like what people can expect from Near.
Yeah, absolutely. So, I mean, the next big launch, I think people have been hearing us talk a lot about AI, but they haven't actually been able to try out the infrastructure that we've created. So, yeah, I guess probably by the time this airs, we'll have launched based agents. So, TLDR on that, it basically is like truly autonomous end-to-end verified AI agents. And what we mean by like, this doesn't even have to interact with crypto, right? Like your AI agent can be, interacting with anything in the Web2 world, buy stuff on DoorDash. It can move money between bank accounts. It can do all of that, but it does it from from within this like trust boundary, this extended trust boundary from smart contracts. And so we believe this is actually kind of one of the missing pieces to really enable both Web3 AI agents and like using AI as like core primitives of DeFi protocols, but even the Web2 world, and being able to like actually automate a lot of commerce like we've been trying to do. So definitely recommend that people check that out. And then the Near AI team, which is working on some very specific products, will also be launching kind of their AI registry that has some like really great kind of discoverability features. They'll have some exciting announcements about how they're teaming up with some of the bigger players in this space to empower kind of fiat on and off ramps to AI agent payments. So you can look forward to that as well. That'll be mostly coming out at ETH Denver.
Absolutely. Well, I'll definitely see you at ETH Denver, and to all our listeners, definitely go to any of the events there. Finally, where can people learn more about Near? Where can they get involved with you personally? Any kind of shout out, any kind of Twitter, any kind of social media handles?
Yeah, so to learn more about Near, I definitely recommend checking out near.org is kind of the Near Foundation's website. So that talks about chain signatures, talks about a lot of like the blockchain infrastructure that Near has built. If you're interested more in some of the AI projects, there is just like a dedicated site there called near.ai. You can do docs.near.ai. You can learn about based agents. You can learn about the agent cloud. You can learn about agent payments, all these different products. And then if you're interested in, we support builders in every single way that we can from proximity. We love working with teams and kind of going as deep as we can with you. Definitely reach out to us. Our website is proximity.dev. You can find us on Twitter as well. It's proximityfi. And then if you want to follow me and interact with me, I'm just Kendall C on Twitter.
Lovely. Well, everyone go follow Kendall, and let's continue building the future of on-chain AI.